And now let's move on to Louis Carr, Senior Director, Product Marketing and Management with Actian, who's going to talk to us about edge data management. Go ahead and share your screen.
Yes, yes. Okay, so we've got about 21 minutes left. We will certainly want to leave time for questions, so I will try to stick to the 15-minute budget we have left then. So my name is Louis Carr. I'm a Senior Director for Product Marketing and Management at Actian. You can look at my profile and on LinkedIn to know what my background is. And I'm not going to talk about the products that I market or manage today. I'm going to talk about what is literally stated there, understanding modern edge data management requirements. If you do want to know anything about our products, you can get an overview of the one that's most closely related to this topic, which is Actian Zen. And that's the URL which you can go and see the information. So, why the point of talking about edge data management? It seems like that would be a pretty ho-hum topic to talk about. But the reason we want to talk about it is really because of edge intelligence. That is, we've got this huge growth of IoT and mobile devices. We've got much more sophisticated, complex network equipment out there, everything from autonomous vehicles to shared MRI devices in rural hospitals. There's so many different applications that we're seeing this booming revolution of edge intelligence in that this is just a few just to get your thoughts around exactly what we're talking about. That whole wave really, if you break it down into tiers, the way I see it, it breaks into what you see here as at the very left-hand side of what you're seeing are devices that may have still relatively little compute power, but because of the low cost of microcontrollers now, because of the resources on those microcontrollers, that developers are even able to apply data acquisition and onboard computational support to do very sophisticated things, including some set of machine learning. And one thing that you hear a lot about is tiny ML fitting into that space. Above that, you have larger MCUs or even 64-bit CPUs that are multi-core, that have significant amounts of memory with them. And now with the advent of solid-state drives, you have everything that enables you to fully embed what would have been only able to run at that level of performance in a conditioned environment, such as a data center where you've got the raised floors and the cooling and everything that, as an early engineer, I enjoyed with VAX 11 780s and so forth that are now all the way down at that grid Sentinels level almost. And above that, obviously, with all of these devices, there has to be that network layer of control. That network layer is increasingly becoming another layer for applications. It's not just a matter of the network management. Those edge gateways are now application platforms. And then, of course, just above that, what would have been in the data center is now shifting entirely towards the front end. So what would have been in a data center is now a pizza box sitting in a closet that's not even air conditioned at a Home Depot or out on a Costco, as in Costco shipping cargo container ship out in the middle of the Pacific or something. And then above that, we of course have the cloud. And the point is that across all of this, there is a communication, a sharing of data, a distributing of not just the data, but the actual applications. And increasingly, as we move towards more and more things adopting machine language and machine learning, you will have this need for developing that machine learning algorithm sitting back in the cloud or in the data center, where you collect a lot of data from up front out on those grids of IoT devices, et cetera, tune against that data to make sure your algorithm works properly, and then run it in an unsupervised fashion in some shape or form, or elements of it, further and further out towards the edge. And what that will mean is that you'll have to have a distribution of the data, a distribution of the intelligence derived from that data, a distribution of the security around that data, the governance of that data, et cetera, et cetera. So in other words, there's going to be more of a need for edge intelligence. Well, if there's more of a need for edge intelligence, there will also be more of a need for the ability to do data management to support that edge intelligence. Now, where will we see that? Well, you're going to see, as you go up that stream, obviously more and more sophisticated needs for that edge data management. And that's what we expect. If you're in a data center, you expect the needs for handling large sets of data, such as Andy described, that you would need for AI ops in the data center. Though all those log files aren't necessarily even coming just from the data center. Oftentimes, as you move into full digital transformation, all the way out to the edge, then the preventative maintenance you're doing, the log files associated with all of the data collected from the components of each device, and obviously the device itself, flowing back into the data center. If this is the case, then obviously you're using very sophisticated data warehouses, cloud data warehouses, if you virtualize that out into the cloud environment. But this is, while being necessary, is insufficient to get to the full need for what you're doing for data management. And so increasingly, as you get more and more intelligence going out into each of those further remote tiers, you're going to need more in the way of edge data management. So one way to look at this is, let's use Andy's Yogi Berra quote. Okay, what was it? Let's see. In theory, there's no difference between theory and practice. In practice, there is. Okay. Well, these capabilities, look at this as the way of looking at, here's theoretically what I need in terms of the capabilities. But in practices, you have to look at what's the solution and the requirements for that solution. And so in our minds, there's really 8 major requirements for modern edge data management. And I've got blogs and much more detail about this on our website. And again, even at that level, most of that doesn't get into our particular product. These are things you should think about regardless of which product, or actually in most cases, products that you're going to choose from multiple companies. The first is the most important. You're going to end up having to manage large sets of persistent data. And I think when IoT really started to become a, something, if you look at Gartner or its equivalent hype cycles, 7 years ago or so, you would find that virtually all analysts, and particularly people in companies like Google or Verizon, would talk about all the data is going to flow back up into the cloud. That's not going to happen. They're just on the basis of latency. And you could argue that, oh, well, I'm going to have far more bandwidth now with 5G, or as you saw before, I also mentioned, moving into Cat-M and other IoT standards to take advantage of 4G, LTE, et cetera. That will mean that you can move that data around faster, and that you have more bandwidth, but it does not necessarily get rid of the problem of latency, particularly when you start adding in more and more devices that are interacting with each other locally at that perimeter edge. For that matter, even the network itself that is delivering 5G will end up having to do much more locally at the edge to figure out how to do the handoffs, to figure out, am I getting the quality of service against the service level agreement, et cetera, et cetera. And in every industry, you're going to see the equivalent of where you're going to need to do local processing and local analytics, particularly as you get to unsupervised machine learning, will require that persistent data. The second thing is that unlike in the data center, where we had really Linux, which is the final winner of the Unix variance war, Windows, And then obviously, as we went to virtualization and then moved into the cloud, we're now really looking at basically three major players: Amazon, Azure with Microsoft, and obviously Google Cloud. When you get out to the edge, you do not have this level of either, homogeneity, or at least just a few large fiefdoms. You have this really fragmented environment. And as a result, when you talk about memory management tied to a particular environment on ARM or Intel or anything else out there, you're talking about multiple operating environments. So any data management you do, if you want to be able to achieve both the persistent local data and the data sharing all the way up through those tiers, you're looking at having to support multiple platforms. The other thing is that it's all about developers. Developers will make or break this. And yes, I mean developers in a very broad scheme, including everything from data engineers to data scientists to people that do the integration and try to stay low code. Taking that in its totality, you're really talking about the need for that data management to be enabled in a way that the entire virtual community around the creativity on these edge platforms has to be able to access that data. And for them to do it, they have to use their standard tools, their standard languages. If I'm a business analyst, I'm more apt to want to use SQL, for example. If I'm a data scientist, maybe I'm more apt to use R library or TensorFlow. If I'm a standard developer, I want nothing to do with a database. I probably want to stay into the level of trying to use direct inline code. Yes, I could do SQL, but I'm more likely to maybe even default or relegate myself to file management. Point is, you've got to be able to handle all these different ways of thinking about how to leverage the actual data that you're trying to manage. The data will not all be the same. Andy even mentioned that you could have some that's unstructured. You could have huge blob files. Obviously, the metadata on it is what's going to help you structure it, but then you're just getting the semi-structured as you would with JavaScript object notation or so, JSON or something. The point is that you're going to have all these different data types, and all those data types aren't necessarily going to be sent up into the data center. If I've got log files that are of a JSON type and I want to look at those log files to make some preliminary decisions, some pre-processing at the edge, then that data management tool has to be able to handle that. If I'm doing AI, chances are I need to take all of that semi-structured data and immediately make it into something structured that my model, my algorithm can deal with. So I've got to be able to deal with all these different data types. I also need to understand that depending upon the process in what industry it's in, there may be times when, because of low bandwidth or disconnectivity, because I'm using various different architectures, if I'm in, for example, a factory environment, I may still need to worry about certain manufacturing like CAN bus or something like that, types of protocols for moving data around that factory floor. And of course, there's still going to be that operational technology to IT layer that come together. So I'm going to still need to be concerned with the standard internet types of environments. I'm going to also be concerned with trying to leverage the developer skill sets that are evolving and the ability to go from that OT environment to look for web services that might be exposed. So maybe I want to use REST. Point is, I'm going to have all these different types of architectures that I need to be able to connect into. I also want to make sure I stay on time. I've got just a couple more minutes. I also want to be able to handle not just the different data types. I want to be able to handle them in the different modes. Andy spoke about the fact that it's not just this big volume of data that I'm worried about. At the edge, you're not just worried about the volume. Even more so at the edge, you're worried about the velocity and the fact that certain data sets, especially if it's for an IoT grid where I'm collecting, I don't know, pressure, volume, temperature at low speeds, but at the same time on that same grid, I've got a security camera overlay to make sure nobody's trying to get in and mess with my, chemical processing plant or whatever it may be. In that case, I've got two different IoT networks that I need to be concerned with, that video surveillance as well as that lower speed set of data. So one is high speed, high data, the other is low speed. I need to be able to collect all of these different data on different channels at different speeds, and then worry about some level of fusion of data to look across different data sets to get more accuracy on whatever operation that I'm doing. And then finally, even though I started out with this is all about developers, there is no situation, as Andy already talked about, the average on operations and maintenance in most companies is still, depending upon if it's government, even worse, somewhere between, let's say, 60% if you're a highly innovative company without a lot of technical debt or you somehow hidden it somewhere, all the way up to good old government where things are something like 80% of your money is just on legacy systems, keeping them running with Band-Aids and gum. Point is that in any situation, I need to be maximizing use of my developers or my business analysts or whatever my technical knowledge base is. So the importance of open standards and being able to use off-the-shelf IDEs, off-the-shelf advanced analytics tools, off-the-shelf reporting and visualization, all the way connected into those downstream devices means that my data management downstream has to enable me to do everything from extracting that data using standard structured query language to being able to leverage using the MicroStrategy or Looker or any of those BI tools, as well as allowing my data scientists to play with Data Robot or TensorFlow and so forth. So that's the actual points that have to be met. Now, I'm not going to go through this in any detail, and I've got lots of blogs on this, but most development teams, most companies in terms of their IT resources are really sitting somewhere on a maturity curve, either at the very low end where they just want nothing to do with formalized, sophisticated edge data management, and they're still in the area of flat files or skunkworks, to environments where they are using very narrow open source tools, to that's just great, to environments where they're just using legacy proprietary, to where they're beginning to bring in enterprise databases, but those databases may not solve across that entire list of different types of requirements that we listed, those last, the 8 that I just mentioned, to something where you're really trying to use a single platform to address all 8 of those requirements. That's the holy grail of where things have to go to. So that's pretty much what I wanted to go through. I'm sorry I went a minute over, but I think I'll turn it over to the moderator for questions.
Okay, well, thank you. You know, that's actually sort of overwhelming. I mean, really, all the things you need to think about, all the possibilities that are out there. And I'm sort of wondering, with your 8 requirements, mm-hmm. do you think that any of them are more important than the others?
Yeah, I think the one that's most important is that you look at something that's going to work on as many platforms as possible, okay, that's modular. So that if I look at the bottom ends of that tiering that I described, right? So if I go down to a device level, mm-hmm. can I use the exact same architecture, the same APIs that I would use back at the data center if I was running in the cloud in VMs or containers versus running directly even in an executive kernel level or on an operating environment that's limited, like an embedded Linux, like let's say Raspbian or something, Raspberry Pi OS. So I think that's the first thing is, can I use a single API? With that API, can I embed it in virtually any type of environment such that everyone has the opportunity to access that data? That's sort of the democratization of data.
Yeah, wow. Well, I think that I don't know what this means. Somebody asked about the last slide.
Oh,
I think maybe Steve, could you put that last slide back up again? I think somebody was trying to
the
get
only thing on my
details.
last slide was my email address, and
well, I think somebody wants to know that.
Yeah.
So maybe you could put that back up since someone asked for it.
I just put into the chat window
okay,
for everyone.
That's how to get hold of Lewis. Since if you have questions for him, I think that both of our presenters this afternoon have given us so many very practical advices going forward. This is really cool. There's Andy's back again. Hello, Andy.
I'm here just taking in all what Louis was saying. It's a lot of good stuff.
I love the way that you can both bring the yogi quote in here.
I thought that was great. Yeah.
Yeah, right.
I gave notice, I didn't claim it as my own. I gave the proper attribution to it.
Very, very good, Louis. I'm impressed. I'm impressed. So thanks to both of you. Thanks to our diamond sponsor, Sumo Logic. We will be back tomorrow at 10:30 in the morning Eastern time. I have to keep remembering now that we're all virtual that you have to keep specifying what time zone you're doing things in. Otherwise, it's very confusing for everyone. So anyway, 10:30 tomorrow morning, it will be our first session for the second day of Data Summit Connect. Thanks again to Louis and Andy for all that wonderful advice and great presentations. So thanks again.
Thank you.
Awesome. Thank you. Bye.